Hello guys, let's start with our SQL beginner series. First video, Introduction to Database and SQL. Let's start with understanding what is data and why database exists. Correct? So let's see here, it's written data. Okay. What is data? Raw facts like numbers, names and dates. Okay. And has no meaning until processed. So what is the meaning of this line? Right? What is the meaning? And what does this line also means, right? If it is not clear, let's try to understand that. Now, let's first understand what is data. Okay. Let's suppose if I say your number 25, or if I say suppose 1 2.6, or let it be something like box. Okay, then let's go and say floor. So what is this? These are some values, right? Okay, now let's look at this thing. I am 25 years old. Okay, I got 2.6 out of 4 grade or CGPA, whatever, right? There is a box on the floor. What is this now? What do you understand by looking at this particular thing? This was something, some value, right? No, but this particular thing is an information. I am 25 years old. I got 2.6 out of 4 grade. There is a box on the floor. So this is an information. This when some non-deterministic values are there or some random things are given to you, it does not make any sense. It is not even a data, right? It These are just values. They are not meaningful datas. But as soon as I get this particular thing, it becomes an information, and from this information you can take out the data, right? Okay, so age of the person is 25, the grade is 2.6. Okay, what is there on the floor? There is a box on the floor. You're getting my point? So this is what we get from information. Okay, this is information. If you understand, if you want to understand more, let's take this example also. Suppose 26 uh, 1 1 2001. Okay, then let's take mm 88%. Again, what is this? This is just a random data which does not qualify to be an accurate information. Correct? But as soon as I say I am, again the same thing, 26 years old, and my date of birth is one. Let's take this as day. Okay, first day of first month at 2001, right? And I got 88% in my boards or my exam boards, right? So this is the information. Now suppose this information you got it from me, and I'm giving this information to you. Now from this, what you can figure out? You will say, "Oh man, this is of information you have given to me." But from here, the important things or the important data which I need and which is valuable information for me is that you are 26 years old, your date of birth is 1/1/2001, and you got 88% in the boards. So this comes out to be a data for me. Okay. So that is what it's written here. Raw facts like number, names, and dates are data, and they don't have any meaning until it is processed. So from information, what we got from there, we got the data, right? And if you process this data, like in a something, if you store it somewhere, then this becomes a meaningful source of information for others. You got my point? This is what a data is, right? And anything can be a data. Anything. Suppose number of likes can be a data, number of comments can be a data, right? These are data which are stored somewhere. Now where it is stored, right? The second part there, I'm coming in that part itself, where this data is stored, right? If I say I have 10 kilos of oranges, and the price of each orange is 2.5 rupees per kilo. Let's take an example. I know it is pretty less, but 2.5 rupees per kilos. So you have the data, but where I will store this kind of data, right? So that where the database comes in place. right? That is why database exists. Why? Let's look. Files fail when data grows. Okay, database organize, secure, and speed up the data. Okay, so I guess I hope you understood some of the meaningful statements from this particular line. Now let's elaborate this particular thing, right? Database. Okay. Now earlier, I'm not talking about today's time. I'm talking about earlier days, right? The people in 90s when they used to store data, small data, because their data was not a lot in those days, right? So people used to store it in Excel, okay, text files, right, and some unreliable source of or unreliable storages. No, that's not an issue. That's not an issue. Yeah, it contains data, right? So that's not an issue. But 100 rows, okay. 1,000 rows, okay, it will work. 10,000 rows, is that okay for an Excel sheet, for a text file? No, it's not, right? How many Excel sheets will you create? How many Excel's uh, pages you will be creating to store this data? Okay, you have created those number of sheets, like 100 sheets you created, 1,000 sheets you created, and each sheet has 10 rows of data, so 10,000 data you have stored. Fine. Now, suppose X person has this sheet, right? I ask him or her, please give me this copy of the sheet. Okay, he shared me the copy. Great. Again, one person is there. He also asked, please share me the copy. I shared the copy. And there are into hundreds of people. Will I keep on doing this? Does that make sense? It does not, right? So it does not make sense, but that is a database because we are storing data there, right? In a short, I can say that a place wherever you can store the data is a database, correct? Now, Excel and text file are not only the databases. It is not, fixed to a point. You will you will be thinking like, yes, table is a database. Yes, it's a database. We store the forms in. Everyone knows this. We have studied this. Rows and columns. Basic things which we learn in schools, colleges. Rows and columns. This is a tabular form of data or database. Sorry, correct. But is that so? Only table is a database? No. Database could be in the form of key value pairs, like a dictionary. You remember dictionary? You have keys here and you have the values here, right? So that is also a form of database. If I go and talk about graph, what is graph? If anyone has studies DSA, data structures and algorithms, or anyone have the knowledge of graph, they know what is graph. If you don't worry. Let me draw a diagram here. Yeah, what is this? This is a graph. This is a node, and this is the edge. Now, can we store data here? Yes, we can store the data here in hierarchical format. Suppose name is stored here, and person's age is stored here, person's grade is stored here, person date of birth is stored here, and we will name each of the node, like it's a name of the node is grade, name of the node is date of birth, name of the node is age, correct? Name of this particular node is name, correct? So if I come and fetch data from this particular node, I will get all the information of the particular student or a person, right? This is a form of storing data. So it's also a database. Then comes the column format database, column format, then document based. Column format, document based is basically JSON format. Okay, so there are multiple ways of storing data. Database is a concept. It is not restricted to a one thing that always a relational table is always be a database. No, it's not true. Correct. Okay. So if I try to conclude what is database, I can say that a database a database is also denoted as DB. Okay, please keep that in mind. D for data, B means base. Database, okay, is a structured way of storing data in a central place So it can be easily searched, accessed, and operated on by multiple users. Fine. Now you will be saying, what do you mean by searched, accessed, operated by multiple users? Look, as I explained to you earlier, the example of these Excel files or these text files and how these data are getting copied and given to hundred of people. And suppose in that scenario, if I have one central place, like I previously explained, you have a graph, column-based databases, document-based, which is JSON-based databases, or like table format databases, key value space, or any other format. You can even create your own format of storing data. So that could be a database. The condition is that it should make sense. That's it, right? So if I create, suppose this tabular form, it will be easier to understand. Suppose this is a database, okay, table. You have the data here, okay, X, Y, Z, O, whatever, right? It is filled with data. Now, there is some admin who has the control of the database, correct? Like suppose the driver has the control of the car, right? And this data has to be shared by hundreds of people, okay? So they can come, take the permission from admin and access the data, okay? Whether they want to read the data or they want to write the data or they want to read and write both the data, right? So this becomes very easier for a place for a person to come and take the data from the source. If more I drop it down to a layman language, it's like suppose this is a departmental store, okay? It has a lot of places to store data, but this is the current data it has to sell to the people or the customers. But somewhere in the back end, they have a cold fridge or a cold storage, okay, in which that they have all their items stored in racks, right? So whenever certain amount gets finished, the employee will come, look for the data where it is stored. Suppose X are stored here, it will take the X, it will go back and store it here, right? So this is what a database is, right? This particular storage. So I hope you understood why we need databases and why database exist and what is data, right? Here I have written something from messy files to a structured storage, correct, right? You have unorganized, ununiform data thrown here and there. Just take an example, your clothes are thrown here and there in the room, but you accumulate those clothes and store it in a cupboard. It becomes a database for you, right? So this is as simple as that. I hope you understood this particular topic, what is data and why data exists. So guys, let's move to the next topic. So moving on to the next topic, which is database versus DBMS versus RDBMS. Okay, let's start learning about the topic database versus DBMS versus RDBMS. So what is database? It stores related data. Fine. If we look at the example, a student data set has a roll number, a name, age, and etc. Right? And a file system is also a kind of a database. Okay. Now let's explore more about the database here. Okay. And before going ahead, in previous video also, I talked about database, right? I talked about types of databases. So if I ask you what is a database, you will not only reply to me as it's a table. No, you might also say it's a JSON format. It might be key value pairs, right? It might be a graph. It might be column based, etc. Until and unless it follows the concept of database, right? And you might also recall and tell me that database is a collection of data. Yes, stored in a central location. Correct? This is the knowledge you gain from the last video or the last topic, I will say, about database, right? But here you can see I've also talked about file system in the example. Now, how file system is a database? Basically, a file system approach is something like uh, data is directly stored. Data is directly stored in files, correct? And you will say what files or what do you mean by files? That basically means .txt format, .csv format, and Excel sheets. Okay, or any custom data files you might create by your own. Now, this each file is stored in separate disk or separately on disk. Fine. Now we understood what is file system and what basically the files are and how it is stored. Now, moving ahead, what is the disadvantages of using this file system, right? And once we talked about this disadvantage, we will be understanding why DBMS came forward and then why RDBMS came forward. Okay, there was no automatic link between files. Okay, first thing. Second thing, no rules were there. No rules or constraints were there or enforced. Okay. The third point, no central or any kind of management was present, right? So we understood this thing. So we understood. First, we recalled what was database, right, and types of databases. Then we came forward and we tried to understand what is file system, as I talked about in the example, right? So file system, it stores data in the files, and we talked about the types of files it stores in, right? And where it is stored and how it is stored in separately on disk. Fine, we understood this thing also. Now we understood the disadvantage of the having a file system in current scenarios or in current world, because this file system is not handled by any kind of application. It is just handled by the operating system. Okay, operating handles it, and there is no application in between which tells what to do and what not to do. What to do, what not to do. Basically, read write. Okay, this is handled by the OS. Now, how the overall structure goes of file system is like there is an application, like we are interacting with the application basically. Then there is the file system, then there is the disk. Okay, so this is the, I would say, structure of file system. So I can from here we can figure out that what are the disadvantages of having the file system, or you could say having writing the things in a organized manners. Now from this particular thing we understood the database, right, and we understood what is file system, and we also recall about the database thing. Now moving ahead, let's talk about DBMS. DBMS. What does DBMS says? What does DBMS says? It says that I'm a software which manages the data stored in files. Okay. For example, Fox Pro, MS Access, DBase, Clipper are some of the examples of DBMS. Okay. Now let's elaborate this particular thing. Now coming to the point, why it was needed. From the earlier slides or the database topic currently we talked about, we got to know about some disadvantages of having or storing the files in the file system or storing the files in an unorganized format, right? Like storing it in an Excel file, storing it in a text file, or somewhere else, right? Which we also talked about in the previous video. But that was the concept of database. What is database and what could be a database? But DBMS is a database. It is like, um, suppose this is a cloud. Okay, this cloud is called database. Let me write it somewhere. Okay, this cloud is called database. Now this cloud, and within this cloud there is DBMS, because DBMS follows the concept of database, right? Because what is the full form of DBMS? First of all, let's figure that out, right? It is called database management system, right? This database is the concept of this database, right? And within this database we have DBMS, which is called as database management system. Now this is clear. Now let's back to the topic, why it was needed. Okay, why it was needed, why it was needed. Now in the previous concept of databases, the things we talk about, like file system or storing files in some kind of database format thing, what is the thing which we were missing? How do you store data, how do you store or search or update this data? Okay, how you will do that? Suppose if I have a I have a box here. Okay, uh, something like this. I have a box here. Okay, and I have uh, into 1000 thousands of datas. Like, consider this as a box and this is a sheet of paper which have details written in it of a particular student, and I have 10,000 students with me, so there will be 10,000 seats, right? I have stored everything here. Fine. Okay, that's great. This is a database, so this becomes a database, correct? Conceptually this becomes a database. Now if you follow the old tradition, how you will search for a particular student from here, you know, suppose you want to search for a student whose name is uh, let's take my name itself, hers. How you will search it? You will go manually. Of course you will go manually. You will take bundles of papers and you will keep searching on the name of hers. Now there could be multiple hers. How you will distinguish that multiple hers? Then you will go for and look for the surname, if that is a unique thing. Otherwise you will go and look for the student ID, correct? Fine. But is this possible every time or every second if you have to do this particular thing, or every hour or every day? It's not, right? It's a lot of work to be done. That's where that's where the concept of DBMS comes. Now in this particular, in the full form itself, if you go to the full form, it says database. We understanding management, we know the meaning of the word management, right? System. So it's a management system of the database. Fine. So here The concept of DBMS comes when this kind of things comes starts to play on. So if I write it here, it is the software that helps you store and manage data. Okay. So this is what a DBMS is. Now let's go more inside the topic of DBMS, like uh, what a DBMS could do, what it could do. We could insert data. So let's take the example of DBase. If you can see here, I have talked about few examples: Foxpro, MS Access, DBase, and Clipper, right? So let's take the DBase example, for example, okay, to understand the thing. Suppose this is DBase, okay, some data is here. This is the interface, okay, interface, interface of the DBase. Now what you can do here, you can insert data, you could search for a data, you could update data, you can delete data, right? You could do this kind of stuffs using this DBase interface, which is a DBMS. This is the first thing. The second thing, in previous database concepts which we learned about files and file system, all those things, there we have to go manually, select everything. Just imagine of a file system or Excel file. What you do, you just go there, you look for the file, you select the file, you edit the file, you delete the file, right? You do all of those kind of things. But here you don't have to go and do anything manually. What you will be doing, you will be writing commands. Okay, what could the commands be? Like select a particular column, suppose select a column and update the value, something like this. Okay, depends upon the platform you are using. There would be commands which you have to learn and you have to implement so that the particular thing could be done, and it makes it very much easier, right? This is what a DBMS is. It's a platform it is platform which brings all the data all together in one place so that people can use it in a technical way. Okay, but what are the limitations? Everything has a limitation, right? What are the limitations of DBMS? Main thing, I will write it here: tables were not strongly connected. Now let me go ahead and explain the limitations. There were no strict relationships. Suppose you have two tables, right? Table 1 and table 2. So if you want to make relationship with these two tables, there was no such, you know, easier way to do it or any strict rules for doing the particular things. Okay, so there was no strict relationship. Now secondly, data duplication was possible in DBMS. Okay, third, integrity rules were weak. So integrity rules means whether the value has to be null, whether the column has to be null, what could the data type, right? uh, Whether there is a default value for the particular column if no value has been added. So these are some of the integrity rules which were not present in the DBMS. Data duplication issues was also present in the DBMS, which they were not able to solve, and no, there was no strict relationships. So boiling down to like primary key concept was not there, not enforced properly, I would say, properly. Then foreign key, same, not enforce itself. Okay, let me bring it somewhere here. Okay, then joins, table joins was not built in few, or you could say very limited. So this was the reason why DBMS failed in a longer run. But this concept of, from the concept of database file system understanding, and getting to know about the disadvantages of those, people came with a solution of DBMS. Okay, then going through the DBMS, new challenges came up as we explained, as I explained here, and some limitations comes because of that. Correct. Now, to resolve these limitations, new thing came up in the market, which is RDBMS. So here, if you can see RDBMS, what is RDBMS? Data stored in a related tables, uses keys to connect data. Okay, so this is the main important line here and here also. And examples of the RDBMS are MySQL, PostgreSQL, Oracle, SQL Server, all of this. Okay, now let's understand more clearly what is RDBMS. Going with by understanding data stored in related tables. First and foremost, what is the full form of RDBMS? It is relational database management system. What is the meaning of this word relational? Okay, we know what is database management system. We learn about that. What is R, or what is its relations? Uh, uh, Stands in the RDBMS. Okay, what happens when data grows? Okay, it grows a lot, number in billions. Okay, or in millions. Let's take it. In nowadays we have data in uh, you know uh, more than billions of data are there. Like, okay, how we will handle this particular data? Let's suppose if a customer data is in one place and order data in another, how do you connect them? How do you connect them? How do you do that? In, if a customer data is in one place and order data in another, how do you connect them? This is the question. It's like, if this is my home and this is me, this is me. How do I connect myself with the home? Of course, I will have some IDs, or I will have a map with me which will take me to the home, right? So here comes the role of RDBMS to solve this, the biggest issue of relationship between the tables, between the data. Okay, this is the main thing which RDBMS comes and solves. How it does it? RDBMS stores data in tables and connects them using keys, right? And these keys are like primary key, which is called as PK, foreign key, okay. Sometimes super key is there, alternative key is there, right? So these are the way RDBMS helps us. Suppose this is a table here, T1, and T2 is another table, okay. It contains, suppose, my surname, and here it contains an ID, okay. It contains my first name, or you could call it as last name also, and it also contains an ID here. Now, if I want to find the last name of this particular, suppose of a person X, what is the last name of person X? So it will have a primary key, which is an ID, okay. So one belongs to hers, or HARSH, hers, okay. And here one belongs to my last name, which is Bansal, okay. Now what will happen? I will join, and this becomes a foreign key for this particular table, and this remains a primary key for this table. Now, using this foreign key and primary key, we can connect these two tables easily like this. The output result will be first name, last name, ID, okay, hers and Bansal. So we joined the two tables to get a accumulated result. So we are not going under what is primary key, what is foreign key. This is the topic of complete database management system. This is a complete theoretical topic. Here we are to learn about what is SQL, right? So this is what you have to understand, how a SQL works. And going further, we will talk about what is primary key and foreign key. But right now, you have to understand what is RDBMS and what is the biggest issue it resolves. So what is the advantages of having an RDBMS? Okay, relationship. There is relationship between the tables. Okay. Second, there is integrities. They brought down the integrity laws here. Thirdly, joins because of the relationships of the table. Then they brought down the consent constraints also, and also we can connect uh, RDBMS, RDBMS with cloud, or also we can either connect them with the cloud, or we also have a cloud-based RDBMS. Okay. So I hope you got the idea of each and every type of things or virtues we were doing, like database, then come the DBMS, how DBMS resolved some of the issues, then what were the limitations of DBMS, then how those limitations were overtaken by the RDBMS, and it basically settled down everything, and everything was resolved at the end, right? So we understood this. Now going back to our notes, I have talked about here DBMS versus RDBMS. Why not database? If we have understood the topic, why I have not talked about database here while I'm doing a comparison between DBMS and RDBMS, it's good. But if you still have the doubt, look, database is a concept, and within that concept, we have the management systems called DBMS and RDBMS, like the cloud. This is a database. Here we have DBMS, and within that we have RDBMS also, right? This is the one. This is That's why we are not putting database in the comparison, because it won't make any sense. Okay. So the features, let's go with the feature, and which is data storage. In DBMS, stores data as a file, right? But in RDBMS, store data in tables, rows, and columns. Data relationships does not enforce relationships between data, as we talked, right? But RDBMS enforce relationships using primary key and foreign key. Normalization concept. This is a concept of database management system. It's a theoretical concept. We might go. or we might learn about this in the further videos if required. Otherwise, while learning SQL, it's not important. So what it does not support normalization. It does not support this management system. The software does not support, but the theory of DBMS has the knowledge of normalization. Please don't mix theory and the interface together. Okay. And RDBMS supports normalization to reduce data redundancy. Query language may use simple commands or non-standard query methods, but RDBMS uses SQL, structure query language, to query the data. Multi-user access typically supports only a single user at a time because mostly it is installed on a single computer or a single machine. Whereas RDBMS supports multiple concurrent users because it can also be hosted in cloud. Scalability suitable for small and simple databases. Basically, people don't use it nowadays, but for a difference, we might consider this as a point. And RDBMS suitable for large, complex enterprise level applications. ACID compliance. This is also a database theoretical concept. ACID means atomicity. Atomicity. C means consistency. Consistency. I means integrity. D means durability. Okay, this is full form of atomicity. If anyone asks you, you can read about its acid properties in Google because this is a theoretical concept. Now in DBMS, it's minimal or no support, but in RDBMS, full support of acid properties to ensure data consistency. So please go through this particular difference table to have more clearness idea. And this is all about DBMS, RDBMS, and database. I hope you understood this topic. Let's move ahead. So guys, let's move to the next topic. Moving on to the next topic, which is what is SQL and how it works. Let's start by learning what is SQL and how it works. SQL, which is SQL, full form Structured Query Language. Okay, what is SQL? A simple way to talk to data or language to communicate with the databases. Okay, a simple way to talk to data or a language to communicate with database. Fine. And what is it used for? It's used for storing, retrieving, updating, and deleting the data. Okay. Now let's understand this in more depth. Let's begin by understanding SQL is simply a language we use to talk to databases. Okay. In simple term, this is SQL. And if I boil down it more, we don't click buttons. Okay. Rather, we give instruction using SQL. Okay. This is what a SQL is in simple term. A SQL is simply a language we use to talk to databases, right? And if I boil it down, it basically means we don't just click buttons. Rather, we give instructions using SQL. Okay. SQL is a query language. Okay. So if I want you to make it more easier to understand by taking a real world example, what I can say is that suppose there is a boss. Okay. This is a boss. He's a cool dude. Okay. He's very busy. This guy is very busy. He have to handle hundreds of things. Okay. So he or she has an assistant. Okay. Let it be he. and his assistant is a she. Okay. Now he's busy doing a lot of things, right? And he knows there is a room which has a lot of documents, or you could say data or database. DB represents database. I hope you understand this, right? So if he goes to that particular room and come back, it will cost him a lot of time, right? And he has to do a lot of works in parallel. So what he will do, he will ask his assistant, please uh, get me a file of year 2025 only. Okay, this is the request he made to this PA, personal assistant. What she will do, she will go to this room, search for the files, and she has her own optimization techniques, own understanding, or own efficiency to figure out that as quick as possible. She received the file, or she got the file. Okay, now she will come back to the boss and hand it over to him, right? This way, it saved the boss a lot of time, correct? They saved a lot of time, and he was able to work parallelly, correct? So he was able to save his time, correct? Time saved, and parallelly he was able to work. Now, this particular personal assistant was only designated to do the work of finding the documents from the room or details from the room, which would cost him extra time. So boss, this boss is the user, okay, us. This personal assistant PA is our SQL query. Got it? So this is the simplest way I can drop it down to make you understand how this particular SQL works and how it help us to save our time and help us to work parallelly. I hope you understood this particular analogy. You can use this analogy to explain someone if someone has to understand it the most layman terms. So this is the example you can take and make them understand. So I hope you understood this analogy of SQL and the client or the boss, right? Now let's move ahead. So now let's see how SQL works. Fine. Now let's see how it works. You write a query. Simple, right? Database or DB understands it, understands it. Then this DB gives the result, right? So this is basically a black box to us. You take it as a black box, like how we can drive a car, right? By hitting the pedal of the car, right? Is it necessary for a driver to know how that mechanism works? No, right? But he should know how to use that mechanism so that the car runs at a specific speed and provides the mileage and it's safe to drive, right? This is what a driver should know, but a driver is not mandatory to know about how that pedal is working behind the car under the mechanism of the car, right? So it is what in easy language you can say, like uh, human language in computer world. Human language is basically converted to machine understandable under, understand understandable language. Okay, so I hope you understood, like This is how a SQL works. Like, this is what you have to know. We write a query, DB understands it, and DB gives the result. And to understand an analogy, I gave you the analogy of a car pedal. Okay, uh, car pedal, right? And also I told you it's like human language is converted to machine understandable language. This is what you have to understand how SQL works in a broader term, right? This is what is required. Now let's try to understand uh, what we can do with SQL. Okay. Now here, if you can see, I told that this SQL is used for storing, retrieving, updating, and deleting data, right? So yeah, that's the thing what SQL does, right? So let's look into that only. SQL helps in creating data. I will just write create data. Secondly, uh, read data, then update data. Fourth, delete data. So yes, this is what a SQL can do. Is that all what a SQL can do? Yeah, there might be, right? But this is the broader terms, or you could say the main core of the SQL. If someone asks what a SQL can do, this is just the reply you have to give, or this is just the understanding thing. You have to say that it can create data, it can read data, it can update data, it can delete data. Okay. Now moving ahead, let's understand types of SQL commands. Now, don't be worried about it, or don't get tense, because this is a thing which you have to understand. But this will be in a broader term right now, like a complete overview. But as we go through in our course, I will explain you each and everything in depth. Okay, types of SQL commands, right? Let's look into that. First is DDL. What is the full form? Full form is data definition language. Correct? Okay. Let's hold there for a while. Second, DML. Data, any guesses? Manipulation language. Let's go for the third one, DQL. Again, what it could be, data query language. Okay, let's go with DCL now, data control language. Okay, then there is the last one, which is TCL, which stands for the transactional or transaction control language. Okay, now DDL, DML, DQL, DCL, TCL. Okay, we understood this. These are the terms, or these are the types of commands. Now, what is DDL? DDL is nothing. It's just create, alter, drop a table. Okay. What is DML? DML is like insert, update, delete. Okay. What is DQL? Data query language. Very simple. Select statement or select query or uh, select command. What is DCL? DCL is basically grant the access. Gr. Okay, let me write it again. Let me write it here itself. Grant, grant or revoke the access. Okay. Now coming to TCLs, it's basically commit, rollback, and save point. I hope this is visible. So yeah, so this is what a types of SQL commands are. Data definition language means defining a database. Defining a database, whether you want to create a database or whether you want to alter the database. This is also defining a database, or defining database means dropping the database. And what is DML? So DML is basically data manipulation language. So things, the queries or the commands which you use to manipulate the database. Okay, these are those commands like insert, update, and delete. Similarly, DQL, data query language, select statement. Without the DQL, you cannot do anything in SQL because everything starts with select in SQL, right? Then comes DCL, data control language. So it is something different. It basically means grant and revoke. So when you want to give or grant or revoke the access of the database to a particular person, these commands are used in that particular scenario. Now, transaction control language, this particular language or this particular query commands are used in the transaction systems when you build, like in a railway or a flight ticket. When you are in a data processing system, like when you are going to buy the ticket, so you just commit the changes each and every time, like you're going to the next pages, right? And when you just go back, suppose let's take another example. This for TCL. TCL is a bit complex. I might understand this. Uh, okay. I hope other fours are understandable. Let's take TCL in a better way. Suppose you are booking a ticket, okay, booking flight ticket, suppose, okay. So suppose this is page 1, this is page 2, and this is page 3. Okay, so in page 1, what you did, you filled up the details. My name is this, I live here, this is my details, this is my government ID, that's it, right? Then you, what you did, from this page you came to the page number 2. So what, so in that particular scenario, what you did a save point. Okay, now in this page, all the details of the payment is written, right? And how much taxes has to be given, and everything is given, and you have to confirm few of the ticks here. Then you have to click on pay button. So you clicked on the pay button and you came to this particular page. Again, save point is done, right? And this page is the final page where you will be shown as the ticket has been booked. So here, what happens? Commit. Okay, let me highlight save point, and then commit. Now, what if you are standing, if you are in the second page and you think of, no, yeah, I have filled some details wrong. So you go to the page 1 again, right? This is where rollback comes in play, right? Similarly, from this is the thing, right? Uh, so this is what how the TCL works. I have tried to use this analogy in a simplest way possible so that you can understand how the TCL is different from the other SQL commands. So I hope you understood these things, and this is but clear. Don't worry about this, like what is create, how to use alter drop. We will learn everything, each and everything in detail as we go through the course. This is an overview of the SQL commands. As previously I said that what we can do in SQL, create, read, update, delete. This is a broader term, right? But if you come and see here, what we are doing, we're creating only in DDL, correct? We're creating here. Uh, what we are doing, we're updating here, create, update, right? We are trying to read here in DQL, right? And even we are trying to delete in the data manipulation language. Yeah, this DCL and TCL also comes in what, create, update, delete, right? So this is what I wanted to explain you in much more depth. So let's move ahead now. This question might come to your mind that who actually uses SQL? Who uses it? Actually, who uses it, right? So it is not like that SQL is for programmers only. No, that is not true. SQL is broadly used by data engineers, data engineers, data analyst, backend developers, even the managers, right? The non-tech persons. I will write it in the bracket. Non-tech persons uses SQL to get the answers from the data. Correct. So this is not all that is what I wanted to make you understand here, that this is a kind of a myth, right? It is a myth that only programmers use this particular SQL. No, if you come to the real world, mostly data engineers and data analysts and data backend developers mostly use this SQL in a heavy way, in a heavy manner, right? Managers also do use it when they have to query some data from the database and look into it whether whatever they are doing trying to achieve. Okay, so this is what you can understand, like who actually uses SQL. Now coming to the final point, but before coming to the final point, let's go to the PPT and look what I have written here. How SQL work, how it works, right? User writes a SQL query, right? He writes something, or he or she writes something in the platform, it goes to the database, and it fetches us the result. Example: select star from customer where customer ID is 10, right? So this is how, in a broader term or in a simplest term, the SQL works. Okay, so let's get back to our final point, which I was trying to explain, is why SQL is so popular. Why it is popular? Just think about it, right? Why it is popular? Till now, if you have understood the thing, uh, and even I have also showed you the command, example command, how it looks like. It looks like SQL became popular because it looks like English and is easy to learn, isn't it? That is why I will say that's why it survived 40 plus years. Let me take an example why it is. As I already showed you the example, but let me take another one. Like I want to check that how many, I want to check that how many students are there whose age is greater than 12, right? So I will write select star from students table where age is greater than or equals to 12. So it's just an English statement, right? Yeah, I here there is something like star select, you know, this particular thing. Yeah, there is, because it's not completely English, but this is how you talk to a database using SQL, right? So it becomes very easy to understand SQL and survive in the world full of data, right? And let's take another example. Like, show me all employees earning more than 50,000. So what I will do, I will just write select star from employee table where salary is greater than 50,000. Okay. So this is what. So this will basically result in giving me the people or the employees who earn more than 50,000, not even 50, more than 50,000. So this is what SQL is. Okay. And if I bring it down in a very, if I conclude this thing of what is SQL is, I would just say that SQL is like English for database. Okay. So I hope you understood today what is SQL is, right? So this is all about what is SQL and how it works. And I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is history of SQL and ANSI standards. Let's start learning history of SQL and ANSI standards. Okay, so who created SQL? This guy plus this another guy. What is the name of the guys? Donald D. Chamberlain and this another guy, Raymond F. Boyce. Okay, I have written some pointers here like IBM research 1970s, first working version 1973, right? Then if you come below, you can see that I have written here early name and industry adoption. What does that mean? Early name, what does that mean? Like it sounds like originally it was called SQL, right? But we're calling it SQL, right? Why? So we learn about that and used by Oracle, Microsoft, and others. Okay, these are the industries who are adapted this particular SQL. Okay, we will come back to this particular topic a bit later. Let's try to understand first these two things, or I would say let's learn about them. So let me take back you to 1970s. Okay, let's go back into the 1970s when databases already existed, but using them was very difficult. So I will write down here. DB existed, okay, but very difficult to use. Very difficult to use. Okay. Now what happened? One day in 1970s itself. Okay, two researchers. Okay, two researchers of whom we talk. I just took the names of. Let me call him Donald, and the second guy was Raymond. Okay, these two guys in IBM or at IBM, they used to work. At IBM, they used to work. Okay, or I would say that two researchers, Donald and Raymond, at IBM. Okay, I hope you understand this particular scenario. So these were two researchers who were working at IBM, or they were the researcher at IBM. Okay, so what happened? One day they thought that let's make the interaction with the database a bit simpler, right? Interaction with DB a bit simpler. Okay, they thought of this. Let's do this. So what they did in 1970, they wrote a research paper. Okay, but in 1973, They developed a working model. Now, can anyone guess like uh, using what language they created another query language? Uh, if not, let me tell you, it was PL1, which means programming language 1. Okay, using this particular language, they created this. So I will just write here um, used this language to create it. Okay, now previously in the PPT, what I said that originally it was called a SQL. So what does this SQL stands for? Also, if you have uh, paid attention, I'm calling this SQL all the time, right? Now I will explain you why is it. You should know, right? Why we call SQL and not why SQL all the time, right? Let me give you a hand there. When they created this particular application, what they named it as? They named it as SQL itself. Okay, which basically stands for Structured English Query Language, right? So this stands for S. So this stands for S. This stands for E. This stands for QUE, and this stands for L, right? So this becomes a SQL. Now later by IBM itself, it was sorted to SQL. Now from this only the SQL came, right? So what IBM thought, or what my thinking is that since SQL was boiled down to SQL, so it was S, right? Structured. It is a structured language, right? So they thought, let's remove this English from here and let's take this query because it's a query language. But we won't be taking QUE because it will be a longer term. So what we'll do, we'll just take Q, okay, from here. And language, yeah, simple. We have to end this SQL with something, right? So it's a structured query language. So this is my thinking that yeah, this is how a SQL might have come up, like SQL, from a structured English query language, which was pronounced as SQL. But rather, now you know why SQL came and from what SQL came, right? So that is why people usually use the word SQL, which is much more easier and convenient to say rather than saying SQL, because you have to take a lot of pauses in that. This is my understanding, and this is what I have observed, right? So to make the learning interesting, I thought of letting you people know like how SQL and SQL came up, right? Now let's move to the second part. In the PPT, I said that we will talk about this later. So what is this? This is NC. I pronounce this as NC. So there could be multiple terms to use, call it. So I just call it as NC. Okay. Which basically stands for American National Standards Institute. Okay. What it did? Common SQL rules. So basically, it depicted some rules, I guess. Then same syntax across databases. Okay. Now let's understand these two particular points which I have discussed here. ANSI. Okay. American National Standards Institute. Okay. So let's move ahead. I talked about that they brought in some kinds of rules, right? So why rules? To avoid confusion. To avoid the confusion, ANSI stepped in that, hey, wait, let's bring up some rules so that everyone can use it efficiently. Okay. So what this helped in? They came in. They said, let's to avoid confusion. Let's make some rules. Okay. So they made some rules. So how these rules helps? So because of this, basic SQL works the same across MySQL. This is a platform for writing SQL queries, right? Oracle, SQL Server, etc. Okay. So because there might be some confusion, right, in all the frameworks which were used to write SQL queries. So ANSI stepped in and said that let me bring up some rules so that it becomes a standard across all the platforms for writing the SQL queries. Okay. Now let's deep dive into more about what confusion basically existed, right? You said you should also know that, right? Since I talked about confusion. So what was the confusion there? So let me write what confusion. Okay. Or let me complete it by saying what confusion existed before NC. Okay. Now this brings makes a complete heading. Now before NC, let me write it like this. Every DB means database. I hope till now you understood this. DB vendor had its own SQL style. Okay, which basically means same task they will perform, but has the different syntax for it. Which also means that SQL written in 1 DB won't work on another DB, right? So it's an issue. It's big. It was a big issue, right? That for the same task, different syntax has to be written, and which also means that SQL written in 1 DB won't work on the another DB, right? So these were the issues, and which is a big issue, right? Because suppose if I'm a admin of a database, I have to learn. First, suppose I learned Oracle, right? I learned Oracle. Great. I can write queries in Oracle. But now I have been asked to shift to another DB. Suppose let's an IBM DB. Okay. Now, whatever the query I wrote in this particular part in Oracle, I won't be able to write in IBM, right? Because they had different structures to write the queries. So because of this, a single person has to learn Oracle also, IBM DB also. Then suppose uh, if there were any etc. Right, etc. That was not feasible during that period of time, right? Because for a same task, why a person should come and learn different types of ways or syntax to write the same thing, right? So this was a big issue in the, I will say, computer world or SQL world. So what happened in 1980s? NC stepped in. Okay, it said that wait, I will bring up some rules so that it will, you know, um, remove this kind of issues. right? So let's see what the query used to be before NC. Okay, NC appeared. Let's take Oracle. Okay, we'll just write here Oracle, which is IBM DB. Okay, IBM DB2. So let's start with Oracle first. It was like select star from students where row num was less than equals to 5. Okay, now in IBM, select star from students fetch FIRST first 5 rows only. Okay, so this was before. What happened after? Okay, it became select star from students fetch first 5 rows only. Okay, so here you can see the difference, right? It's clear. They used to use this row num. Okay, and here they used to use fetch first 5 rows only. Now even in some of the DBs, this is the example which I was able to get as much clear as possible. So in some of the DBs, even this select statement was also written in a different way. Even in some of those statements, star was not given, right? So here the main difference was like if I'm an Oracle DB owner, I know this statement, right? But as soon as I'm coming to IBM, I'm not able to do write this particular query. I have to learn this extra query again, right? Which is a headache. Now this is only the one example I have taken here, but there will be multiple cases. So what ANSI did that do one thing, everything will be same. Like fetch first 5 rows will be used both in Oracle as well as IBM, right? And also etc. Other DBs which were present during that period of time. Okay. Now coming further, if I take the example of MySQL for the same example, and also I wanted to inform here that this was uh, before, right, 1980. So after, when I say after, it was during 1986. Okay, 1980s ANSI stepped in 80s it stepped in, but in 1986 it gave the proper structure. So now let's move to the next slide. Now let's take this MySQL example which I was trying to show here. For this particular same query, it can be written as select star from students. Okay, limit 5. Great. Let's take Postgres also. PostgreSQL. So these are the SQL platforms, right? These are the DBMS, database management systems, right? So here also, how I will write the same query: select star from students, limit to 5 again. So yeah, what you can see here, you can see that this structure has been much more modified and much more restructured to a easier version, so that people don't have to learn a lot of syntaxes, correct? Because NC kept on improving from it started in 1986, and it got improved every year, or every 5 years, 10 years, whatever, I don't remember, but till now also it might be working on this, right? So this is how ANSI worked, and how it brought down multiple syntax queries into a structured way, so that people could learn it more efficiently. So in today's world, if you learn MySQL, right, you can easily learn Postgres, Oracle, and SQL, Microsoft SQL Server, everything, every this DBMS you can learn. Okay, so I hope this difference of ANSI stepping in is clear to you. Now, just just the add-on on this particular topic, I will just try to explain or inform you about some of the things about ANSI. Like I will write heading as ANSI defined core SQL syntax, I would say. Okay, this is a good heading. Now let's take, okay, like some standard data types, I would say. Okay, data types, I would write it as data types. For example, um, int varchar, then date, then decimal. Okay, let's take another, like some standard operations. um, Select, insert, update, etc. Okay, similarly I will take another example, like constraints. I would talk about constraints here. Constraints, like primary key, foreign key, unique, etc. So these were them of the data types, operation constraints, and even some standard joins were also there. Standard joins. Uh, then yeah, if I go to the standard joins, let's take some examples like inner, left. These are the syntax, okay, right, and etc. So these were some of the standards they brought in. I'm taking only few examples here, the important core examples which we daily use in SQL. So these are the things which it bought, and also it standardized the way of writing, which is finally a proper mannered way. Like select, I will write select here, then I will write from, then where. Okay, take another pen, white, columns, table, and the condition. Okay, so this was the standard query structure given by ANSI. Fine. So this is what the ANSI give us about everything. But even though like ANSI standardize the core SQL, but vendors are still free to add some extra features to make some uniqueness in their particular platforms. Like uh, in MySQL, we use limit, right? As you saw earlier. But in SQL Server, for the same limit, we have the top key syntax. So these are the minor modification that which they can do to make their platform a bit different from the other one, right? So this is all about history of SQL and ANSI standards. Okay, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is types of databases, OLTP versus OLAP. Let's start learning about the topic types of databases, OLTP versus OLAP. Okay, now I would like to take a guess here that you might have heard about these two topics, OLTP and OLAP, for the first time in SQL while learning SQL, I would say, right? Now let's explore more about what is OLTP and OLAP. Okay, so what is OLTP? OLTP stands for Online Transaction Processing. The full form itself depicts the meaning of OLTP, right? So it's a thing which is something online, deals with the transactions and processing. Like it's process something, right? Which is online transaction. Okay, so it is used for daily transactions. Fast insert and update. Small queries are done. An example of OLTP is basically where it is used is in banking systems, e-commerce orders, ATM transactions. Okay. Also, let's look into OLAP, which also stands for Online Analytical Processing. Here also you might have, guessed the idea like, okay, something is online processing, getting processed, which has to do something with analytics, right? Something like that. So it is used for analysis and reporting and works on large data sets and has complex queries. Suppose to take out the sales report, business intelligence dashboards, and etc. Okay, so this was the brief of what is OLTP and OLAP. Now let's deep dive into the further explanation of these particular topics. Now, before going ahead, let's start with small steps, right? Suppose let's take or let's understand database are used for two main purpose. Okay, what are those? To run daily business work, and second, to analyze business performance. Okay, so basically what I'm trying to say here is that this is OLTP and this is OLAP. Okay, to run daily business work we need OLTP, and to analyze business performance we use OLAP. So I know it's not clear till now what I'm trying to say here, so let's move ahead and try to understand. Now let's understand this by taking an analogy of a boss. Okay, there is a boss. Okay, he's a boss and he has two employees working under him. Okay, let it be worker 1 or let it be worker 2. Fine. Now what does worker 1 does do, right? So worker 1, what does he or she do? or I will write they. Okay, they handle a daily task immediately. Okay, what does that mean? That means that take orders. Okay, update the stock and receive payments. Fine. And what do worker to do? Right? He sits with report and tells the boss which product sold the most, which month had highest profit. Okay, and what should we improve? So you got this point, right? That there is a boss. He has two workers. One handles the daily tasks immediately, and another does the work on reports and tells the boss about the performance, right? So again, from here we can break it down that this worker is an OLTP worker and this worker too is an OLAP worker. I'm trying to break down what is OLTP and OLAP in easiest way possible so that you could have the idea in a most simple way. Okay, so this is what basically the OLTP and OLAP is in practical world. Now let's move ahead. Now let's try to understand how both of them work, right? How they work in a very brief manner, or I would say in a overview type how they work. OLTP, how it goes is that we placed an order is placed, payment is done, stock gets updated. Correct. And examples for OLTP is like train booking. Okay, um, order food online, and also I mentioned ATM, right? So these are few examples. Now what is OLAP and how it works, right? It's a bit different than the OLTP. Like we try to ask the questions here, like you ask a business question here, like uh, how many orders happened this month? Okay, this is the question. So what OLAP does is it gives you a report, gives a report of it. Okay. Also, let's take more example. Hmm, which city has highest sale? Okay. Then which product is most popular, and etc. Now you might be thinking that I'm repeating the same thing in different ways, right? Like previously, I tried explaining by giving you the simplest example, right? To run daily businesses work, we need OLTP. To analyze business performance, we use OLAP. Then I tried to break down that particular thing by using an analogy of a boss and two workers, right? And how worker one works and how it represents an OLTP, and how worker two works and how it represents the OLAP. Then again, I tried explaining you how they work, like OLTP and OLAP. So I tried giving an example, a very brief example, by taking an example like that. We ordered is placed, payment is done, and stock is updated, and these are few of the example, and these are few of the examples which I took, right? And similarly for OLAP, how many orders happened this month? So this is one of the example. Like this is what it is, right? It gives a report of it, right? And I also tried giving you example like which city has the highest sale, which product is most popular, and etc. So this is clear to us. Okay. Now heading back to the PPT. So here I have brought down an example, right? Application of OLTP. Okay. Now let's try to understand this particular diagram. We just paste the diagram here. So yeah, this was the diagram, and it says that application of OLTP. Now we are trying to go in a more depth in this particular scenario here. Okay, so let's try to look at the left side here. What it says? It says that dispersible data sources. Okay, basically these are the different places where business data is generated daily. Okay, these are the areas from where the business data is generated and basically stored, whatever you can say. Okay, for example, OLTP database is there, Excel is there, Access database is there, and text files is there, right? Now this OLTP database here is main source of live transaction. Okay, so this OLTP database is the main source of live transaction. And what could be these live transactions? You can take any examples like banking transfers, orders on Amazon, or you know, DoorDash, anywhere like ATM withdrawals, ticket bookings. There could be multiple live examples in which the transaction happens concurrently in every second or every minute or every hour. Okay, so what OLTP is doing constantly is that it is inserting. Where should I write? Okay, I will write it here. It is inserting, insert, update, delete. Okay, this is the main thing which OLTP is doing continuously. Okay, now whatever data is particular stored in this particular database, this OLTP database, suppose all the transaction data and everything is stored in OLTP database. Now we copy the complete data from here. We copy the data. We'll write here copy the data, and we try to store it in a separate storage, which is this data mart. Okay, I hope this arrow makes sense now. Okay, so it copies and stores in the data mart, or we could call it as data warehouse. What is data warehouse, or why data warehouse? Data warehouse is basically where we store all kinds of data for our use case. Okay, in very short form. And but why we are using this data mart or data warehouse? Look, just for your understanding, data warehouse is a big, suppose a room or a room. Just take it as a big room, and data marts are small rooms within that big room. Okay, so this is data warehouse, and this particular thing is data mart. Fine, I hope this you understand. And data warehouse stores the data. Let's stick it till that point. And data mart stored some more specific data within that complete data warehouse. Okay, so let's that's knowledge is enough to understand to go further with this OLTP concept. But why do we use the data warehouse if we are already storing the data in the OLTP database, right? I will write it here because we don't because you don't want um, reporting queries to slow down the OLTP system. Let me write here why data warehouse. Okay, because if we try to fetch the live data from the OLTP database, directly, it will make the OLTP database slow. Why? Because first thing, it is taking data from a source. It is using its time and efficiency and power there. And in that particular database, we are trying to fetch data also in the same time. So this will give a very big load on that particular OLTP database. So this load might hamper the performance of this OLTP database and also might give us the incorrect results. Fine. The results won't be as sharp as possible. So that is why the people came and thought that we should use a data warehouse and we should copy the data from the OLTP database rather than querying it directly from it. Okay. The real example could be um, the real example which I can take is of Amazon. Let's think of Amazon order system is OLTP. Okay. But Amazon's monthly sales report is not generated from OLTP directly, right? They first move the data into the warehouse from the OLTP, right? This is what they're doing. Now here you can see there is a OLAP cube present, right? So after data is stored in the warehouse, we organize it for our analysis using something called OLAP cube, right? What does this cube mean? Cube means that data can be viewed from multiple angles, right? Multiple angles. What does multiple angle means? I will write it here. Uh, I will write first multiple angles. Multiple angles. Okay, and that could be product wise. That could be region wise. What else? Um, let's take customer wise. So here we are trying to look at the particular data or trying to analyze the particular data on multiple angles like product wise, customer wise, region wise, city wise, multiple things could be there, right? I have just taken a few examples here for your understanding, like which city has the highest revenue. This could be the questions which OLAP Q basically answers. Now, what is the step 4? Step 4 is this. Let me write here also. This is step 1. This is step 2. This is step 3. And this is step 4. Okay. Step 4 is basically reports and dashboards for users. So this is basically reports, dashboard, and dashboards for user. Okay. So at the end, what we understood from the application of OLTP and this particular process of OLTP is that the main source of live transaction is stored in the OLTP database. We copy those data from this OLTP database and store it in our data warehouse. So we don't have to query anything from the OLTP databases and we don't have to hamper the performance of it. Rather, we will work on our data warehouses. Now, from the data warehouses, we send the data to the OLAP. And why? And here we have written OLAP cube. OLAP cube means meaning we look at the data from the multiple angles. Like now the data we have, now we have to analyze the data product wise, customer wise, region wise, and some of the questions which can come to our mind is that, as I already uh, said before also, like which product sold most in 2025, which city has the highest revenue, which is the yearly profit trend, etc. Right? And this, who wants to look at these data? Of course, the managers, the analyst, the executives, they want to look at this data, right? So this, in these particular dashboards, they try to look at the data. I will just write here like analyst, managers, right? They want to look at this particular data. So this particular diagram was mostly focus on application of OLTP. So this is how the OLTP is one of the part of the complete process. So I hope this part should be clear to you. Now let's move again to the PPT and look at it. So the next diagram is about application of OLAP. Okay, the OLAP process. Now let's go in much more depth on what is this OLAP process. Okay, so I will just paste the diagram here first. Yes, this should work here. Okay, so application of OLAP. Let's try to understand this. First thing is step one. Okay, let this be step two. Let this be step three, and let this be step four. Four. Okay. Then let's take this color. Now you might see that I have not mentioned about the OLTP here because this diagram is much more focused on OLAP. Now since we already know about the OLTP from our previous slides, now let's just focus on OLAP, which we already know, but I want to make it much more clear to you, like how data is prepared for online analytical processing, right? So we know the data sources is OLTP, Excel, what are there? Access data and text files, right? Everything is there. Now we also know that those data is getting copied into the data warehouse. And why it is getting copied into the data warehouse, we know about that also. Correct? Now you might have a question like why you are storing the data in the data warehouse, the live data, right? Look, the analysis which is done by the user through the OLAP process is basically done on the historical data. Okay, let me write it here. Historical data for analysis. I hope this makes sense now. Okay, because you cannot do the analysis on the live data because the output which we will be getting every second will be different, and that is not the case what an end user needs. The analyst, the managers, they want to do the analysis of things. To have the analysis of the things, you see, you basically need some historical data so that you can patiently sit and work on it. Correct? So we also try to understand that what is OLAP, okay, and why it's called as OLAP cube. Here we try to answer the questions, and in this particular thing, I will write the questions here also. Like first question could be same questions again, same thing. Which month had highest profit? And this analysis cannot be done with the live data, correct? So that is why OLTP is not used in this case. That's why we put the data in data warehouse, and through the OLAP process, we give it to the end user. We try to look at the trend, etc. using this OLAP process. And now you might be thinking that you talked about inserting, updating, delete. These are the queries which run in OLTP databases, correct? Because it's a database, something has to be queried there, right? So what is done in the OLAP? In OLAP, the data engineers, I would say, yeah, I would basically say data engineers work on the data fetched from the data warehouse, and that thing is basically called let me edit here, analytical queries. So they use the analytical queries here. Basically, the concept of transformation is there. They transform the data in an efficient manner and distribute the data so that the end user can look at the result. Like using the SQL queries, you can say, or you could use PySpark or whatever they use something here. Okay, so we won't be going into that, but you have to understand what they're trying to do here. And the end user, again, let's talk about the end user. They will just go and check that. They will just ask the question, give me the trend, give me the result of something, right? Give me the uh, revenue report, etc. Right? This is what they will be doing. So this is how the OLAP is. I know both the diagrams look same to you, but I just wanted to point out this particular 2 3 points here, which was based on OLAP. Okay, so let me just point this out. This is the analytical queries is used here, and these are the questions asked. And yeah, so this is the thing about application of OLAP. Now, so again, moving back to the PPT, here is another diagram, right? So this is not much to understand here, but I will try to give an idea about this also here. That what is the key difference between OLAP and OLTP? Since we understood the difference already, I hope you understood the difference already because I have tried to explain it in a simpler way. But here, if you can look in the business process, what actually happens? Okay. So let's coming back to the slide, and I will just paste the diagram here. Okay. Here in business process, OLTP DB is present here, which does the data transactions. Operations is done here. Okay. Okay. Then from this OLTP DB, the OLAP DB is present, which is basically the business data warehousing. Okay. And from there, we do the data mining, data analysis, and big data. Things are done here. Now, I know you might not be aware about these particular terms, data mining, data analysis. Data mining means you know the meaning of the word mining, right? So if I tell you gold mining, what does gold mining means? Then you go to a source and where you do the mining to get out the gold. So that is basically you can take an analogy to understand the data mining. And data analysis, simple. You got the gold. Now you do the analysis of the gold, whether how pure that gold is, right? Same thing here. And then big data. Big data means this is a new term which has came to the world, which is big data. Big data means now the data are not only in millions and billions, but the data is present in trillions, and some even say that data is present in quadrillion, right? I know it's a big, very big terms and words. So to handle those data, the big data concept is there. Okay, we won't be going into that, but yeah. So these are the things which is handled by the data engineers. Fine, and this is done by the data engineers mostly using the data warehousing tools into the OLAP DB, and this is used for information purpose. So this is what it is. There is nothing to understand here in much more depth. I hope I was able to make you understand about this particular thing. Now let's move ahead. So here you can see I have talked about when to use OLAP and when to use OLTP. Okay. Now let's deep dive into this particular diagram and try to understand. So let me paste the diagram here. Okay. So when to use OLTP and OLAP. Fine. Let's try to understand that. If you can see here what I have written, OLTP client, OLAP client, this is a database cluster. Okay. So OLTP characteristics is that when do we use when we have many transactions. Okay. The latency is sensitive here and small payload should be present and the balanced read write is there or heavy read write workloads are present. Okay. And when to use OLAP and what is the characteristics of OLAP? Now, by learning the characteristic of some process or of some syntax, you will come to know, right, when to use what. That's why it's written here characteristics, and I'm trying to point out like when to use, like when you have fewer transactions and throughput is sensitive should be there and large payloads are returned here, heavy read workloads is present rather than writing. Now here you can, since we have talked about the application of OLAP, application of OLTP through that process, and also by taking a few of the examples before I took, right, you can just make out right why they are saying that small payloads is required, many transactions happens in OLTP, why there is only heavy write not read, and here heavy read is present not heavy write. Correct. Now I wanted to point out here about this latency sensitivity. Okay, what does that mean? uh, Latency sensitive. Okay, what do you mean by this particular term? Like, okay, it means that latency is equals to time taken to get a response. Okay, this is the meaning of latency. And what is, and latency sensitive means response must come very fast. It makes sense, right? If you are in a ATM, if you are ordering a food, you cannot wait for 1 hour or 1 day to get the result, right? You want the update quick, both in the client side and in the user side. Correct. That is what, that is why it is latency sensitive. And here also I also like to point out in throughput sensitive. Okay, throughput sensitive. What is the meaning of throughput? It is basically amount of work done in a given time. Correct. That is the meaning of throughput. So what would be throughput sensitive? Total data processed matters more than speed of request. Okay. So I hope this, these are the main important meaning you should be knowing. And after knowing these particular things, you will come to know what to use and when to use. Right. Uh, so basically, this is the, transaction faced side. In much more, I want to make it much more clear to you. This is basically more, much more, client or transaction facing side, and this is much more towards the analysis processing side. Okay. So this was all about this OLTP and OLAP, the type of databases, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is popular SQL databases. Let's start learning about the topic popular SQL databases. Okay, so some of the popular SQL databases are MySQL, PostgreSQL, Oracle database, Microsoft SQL Server. So if I try to draw a line here, MySQL is this, PostgreSQL is this, Oracle database is this, and Microsoft SQL Server is this one, right? So just remember these logos so it's easier for you to understand them. Okay, let's move into the slide and understand their properties. So it's MySQL, which I talked about. It was PostgreSQL, it was Oracle DB, it was SQL Server, Microsoft. So in this particular video, we will try to learn about the differences between this, right? Differences, because these are some popular, right? But we also know have to know about the differences. What is the core difference between them, which makes them unique in their own way? Okay, let's head back to the PPT again. So let's bring this table to our notes and try to understand. Okay, so let me fix this first. Okay, so I hope this is good. Okay, so this is MySQL, PostgreSQL, Oracle DB, and SQL Server. So when was all of these applications, I would say, invented? Okay, like it was invented in 1995 by MySQL AB. It was invented in 1996 by PostgreSQL Dev Group. 1979 Oracle Corp. 1989 Microsoft. Out of this, Oracle DB is the oldest one. Coming to the cost, MySQL is free but paid for the enterprise version. Of course, in enterprise version, it will provide much more features and facilities. That's why it is paid in that particular scenario. Postgre is completely free, even for the enterprise version, I guess. It's completely free. And Oracle DB is expensive licensing cost. So you cannot, a normal person cannot take Oracle DB and start learning on it because it is basically very expensive. And MNCs only target this particular type of DBs. There is Microsoft SQL Server, which is also paid, and free express. Both the conditions are there. Now license, MySQL is open source. It is GPL with commercial options from the Oracle. And Postgres is also open source. Postgres SQL license is also there, which is permissive. Oracle DB is proprietary, commercial use only. SQL Server is also proprietary, commercial only. So basically, this SQL Server and Oracle DB is mostly enterprise based. Okay, and MySQL and Postgres, they are enterprise based, but they're not mostly used by the big MNCs. These are much more focused by small startups, mid-sized startups, right? Or private companies which do not have a lot of data or do not have a lot of data to hold on, right? Like if you can see here, primary use, MySQL is used in web applications, reading heavy operations and simple setups, right? And Postgres works on complex queries, data integrity, enterprise level features, custom data types. Oracle DB's enterprise system, large scale data warehousing, mission critical applications. And also SQL Server, enterprise system, strong integration with Microsoft ecosystem, OLTP system is also present here. So if you can see here, each of the particular, I would say, platforms has its own, benefit. Like SQL compliance, it's written here less compliant with full SQL standards, offers some extension. That means that MySQL almost has everything in it. Like it 90% thing, I guess it has around everything 90%. Those 10% are exceptions, which can also be fulfilled by using some extensions. And that is what is fully covered by Postgres, Oracle DB, and SQL Server. Okay. And here you can see in SQL Server there is another thing uses T-SQL dialect with proprietary extension. So it is nothing different. It's just a kind of a SQL they are using. But yeah, in performance, known for high performance speed in simple read heavy applications, performs well with complex queries and large data sets, can be slower for simple reads than MySQL. Right? You got the difference, right? If I use PostSQLs in smaller reading applications, it will be a slower one. But here MySQL will excel. Similarly, Oracle DB has the high performance, particularly with large data, volumes, and robust indexing. Similarly, SQL Server is industry leading performance for specific workload, caches, and execution plans. What is best for initial learning? This is the best choice. MySQL is the best choice whenever you come down to learn SQL. Postgres, after the basics, what does it mean that you got the complete knowledge of SQL, because there are some of the operations which are not possible in SQL. There is a workaround for it, but yeah, if you learn complete SQL, which we will use in this particular course also to learn the SQL, it's all right. If you learn MySQL, PostgreSQL will be same process to use. Oracle DB same process. SQL Server same process. It's written here not a beginner friendly because it is really enterprise based and there are some complexity present in it. Similarly, SQL Server, it needs the ecosystem. So if you learn MySQL, everything is easier for you. Okay, so that's why what is best for initial learning? MySQL. An ecosystem and support. MySQL has large community, wide range of tools. Postgres has active community, wide varieties of extension and documentation. Oracle DB, extensive official support. Official support means directly from the Oracle. Robust recovery methods and many enterprise features. SQL Server, strong integration with Windows Azure environment, comprehensive official support. Okay, these are the official supports provided by the Oracle and Microsoft SQL Server. They have the community, MySQL and PostgreSQL. Okay, so these are the differences between all the four most popular MySQL databases, I will say, DBMS or RDBMS, whatever. Okay, so this is all about the popular SQL databases, and I hope you understood the topic and the differences between them. So, guys, let's move to the next topic. Moving on to the next topic, which is SQL versus NoSQL. When to use what? Let's start learning about the topic SQL versus NoSQL. When to use what? SQL databases. A structured table based data which has a fixed schema or a predefined format and strong data accuracy and rules. Fine. This is what a SQL database is. And NoSQL database is a flexible data structure. Okay. A schema can change anytime, handles large scale data easily. So this is basically what a SQL database is and a NoSQL database is in nutshell. And if you come and look at here, like when to use what is we have to based upon the data type and consistency which is needed, scalability and performance according to that particular thing, right? Let's deep dive into our more in-depth explanation. As you can see here, I have written some notes like SQL databases work by storing data in fixed tables with proper rules. Okay, and when we insert data, the databases first checks constraints like primary keys and foreign keys, and then saves it in a structured format. Okay, for example, when a student is added, the roll number is verified and the record is stored correctly. SQL is mainly used when data must be accurate, relationship matters, and the format remain consistent, such as in banking systems, payroll, inventory, and ERP softwares. Right? Because in if you can see in banking systems or in payroll methods or in any kind of an inventory or a ERP software, the data is always consistent, right? And before creating the schema, we have a diagram that okay, we will be having only this kind of information with us, and this will be the columns, right? And that is not going to change in near future. On the other hand, NoSQL databases store data in flexible way without strict structure. When you insert data, the database accepts different formats and saves it quickly, making it ideal for fast changing and high volume data. For example, Instagram posts, comments, and likes are updated continuously and with varying structures, right? So, like in suppose there is an Instagram post, right? This is a post, and comment has been given here. Fine. So there might be a scenario that in one particular post there could be hundreds of comments, there could be likes into hundreds of likes, right? But there could be of the same person, there could be another post with zero comments, okay, and 50 likes, right? This is a basically dynamic data which is changing continuously. So NoSQL is commonly used for WhatsApp chats, social media data, app logs, and real-time analytics because it scales easily and handles big data efficiently. Correct? So this is a kind of an overview or a difference between SQL and NoSQL databases, right? And when to use what? Let's figure that out. Uh, but this particular paragraph gives you an idea about when to use what, basically. Okay, but let's deep dive into that particular scenario. Okay, so both SQL and NoSQL are databases, correct? Both can store data, but the real difference is how strict their data structure is. Secondly, how the system is designed to scale. Okay. Now I hope you got the idea, like when to use a little bit of idea. I won't be saying an idea in very depth, that when to use SQL and when not to use, and when to use SQL and when to use NoSQL, right? In which kind of scenarios this particular databases are used, right? Now let's deep dive into this particular thing, and let's take an example here of a banking system. Okay, banking system. What is data bank stores, right? It stores account number, um, name, and the balance, right? So this is what a banking system stores, right? Some data is there, 1H1000, just a random data I filled here. Fine. So everything is fixed, right? Here everything is fixed. Everything is fixed. What do you mean by fixed? Fixed means the column names, right? Or the schema is basically fixed, that this is the banking system and these are the data we will be storing in our particular table. That is fixed. We are not going to change that. Every person will have the account number, every person will have the name, every person will have some amount of balance. Either it will be zero or it will be an X amount, right? There has to be something. And so why SQL is best here? Why SQL is best here? Okay, why SQL is best here? Because there are rules while storing the schema, right? Very strict rules, as you can, as I already told you, right? They have primary keys, they have foreign keys, they have some constraints which are already defined, which you cannot, touch, or you cannot manipulate them. Then there are relationships. Thirdly, no mistakes can happen. There are always relationships, like using primary key and foreign key. They join two or three or multiple tables to get the data of a particular person in a banking system, right? If you go further, now if you can see that one account number number should be unique, then uh, transaction all should always match. Transaction always match. We'll write like this. Okay. Then balance should always be correct. All right. Now, how these things are enforced? These are enforced using primary key, foreign key. Okay. So these are done using these particular things, right? But why not NoSQL is used in a banking system, right? Or I could say, why NoSQL is not used where a SQL is being used? Look, we can use NoSQL, that's not a big deal, but there are some rules and regulations, right? They have a differentiation between them. Suppose if you try using NoSQL, right? Why not um, NoSQL for banking? Why, right? Because of the flexibility, because of flexibility it provides, right? Because NoSQL provides us the flexibility, and because of the flexibility, it becomes riskier because you cannot have a flexibility while storing the data in a banking system. For example, transaction one, transaction one will look like something like this: amount. Yeah. So this is the format how data is stored in NoSQL. If you don't know, okay. And we call they don't have tables, right? They don't have tables, they have collections, right? That is also a big difference in SQL and NoSQL that we are not going into. But yeah, in SQL we just have tables, right? But in NoSQL we don't have tables, we have JSON like format, and which are, and these tables are basically called collections. Okay. Now there could be a transaction 2 with data like this: amount 5,000, and the user is Rahul, right? Now, because of this particular scenario, there is no strict or guarantee option towards the bank that every record which it's filling up in its database is correct. That is why NoSQL is not used in these particular scenarios where the database strictness is required, right? Like I explained here, data has to be accurate, relationship matters, and the format has to be consistent. That is the biggest requirement. Okay, like banking system, payroll system, inventory, ERP software, and there could be many more. Okay. Now let's take another example. Let's take the example of Instagram. Okay. What is the data of Instagram? Mm, suppose post, text, images, comments, likes, emojis, mentions, replies. Correct. Suppose Instagram had these particular things at some time, right? Suppose X years. Now, after some months, like X plus 5 or 10 months, new things were added. Then again, after X plus 15 months, new options were added, right? So new features are added every month or every 6 months or 3 months, whatever their thing is. So it's getting added into the same table, okay, or into the same database. So to handle this particular dynamic changes, I would say dynamic changes and dynamic updates of the particular columns and things. NoSQL is not a helpful database in these particular scenarios. Now, look, for example, let's take this post text. Okay, then let's take images. Let's take these two examples. So we have some data here and we have some data here. Great. Now there is another post text, images. Then suppose there is comments and there is replies. Now what happened? We had the data of the post here. Okay, we had the data of image, we had the data of comments, now we had the data of replies. Now the comments and replies will have another sections because comment could be of into 100, replies could of that comments would be of 100, right? So it's a dynamic data, and in some post you might not have comments and replies, so this part would remain empty. So this would keep changing, right? Suppose this was the post one and this was the post two. So you can clearly make the difference, right? So in post one, there was no particular data. Similarly, here it's dynamic, right? We don't have to put anything extra. We keep on changing the stuffs, but in banking systems, in payroll system, you cannot do such kind of things. It has to be consistent and has to be accurate, and those things are not mandatory in particular example of an Instagram. Okay, so now if you say why not SQL for Instagram, okay, because SQL would require fixed columns, same format for every row, and accuracy of the data, and the, I would say, consistency. Okay, this is the reason why we are not using SQL for Instagram, because the things will keep on going in the NoSQL kind of a thing, like add the column for GIF, add the column for reactions, add the column for replies, now add the column for something else, right? That is a never ending process, but in SQL there are limitations. In NoSQL you could say the limitations are not that much. Okay, so I hope you're getting this particular point, when to use and when not to use NoSQL. Okay, so just to bring this topic or into a layman terms, or let's boil down these particular things which we learned. Okay, what I can say is that by taking an analogy, like SQL is like a passport. Okay, SQL, let me change the color of the pen. SQL is a passport. Let's take this. Okay, now every detailing password is required, right? You cannot just go and say that I won't be providing these particular details, like name, um, date of birth, then nationality, passport number. Okay, and no extra fields are allowed. This is it. Fine. It's a strict format. Now, similarly, if you take this analogy for NoSQL, it's like a, again, social media platform. Okay, one person has, suppose one person has photo plus bio of them, right? Then another person might have like photo plus bio plus links. Okay, now another person might have a business account, okay, plus a shop attached to it, plus a location. So it's flexible. Okay, so you can take this analogy to understand, in real world, like how passport is a SQL part and how social media is basically a NoSQL type of a database. Okay, so let's move ahead. Now, if you go into the PPT, I tried explaining here about data types. Basically, choose based on data types, consistency needs, scalability, and performance. Right. So what I meant by saying those is that we'll just write here consistent consistency and scalability. Okay, consistency equals what? Data must be data must all data must always be correct. Okay, like for example, bank balance must update properly every time. Okay, and what does scalability means? Scalability, system must handle more and more data or the users easily. Fine. Example, WhatsApp must handle billions of messages daily. Okay, so here I can just say that uh, for this particular thing, SQL system care about correctness first. Okay, correctness first. For scalability, NoSQL system care about handling huge growth fast. So I hope you got some idea regarding this particular thing. Like consistency is data must always be correct, and scalability means system must handle more and more data users easily. So in case of SQL, both of the things matters, but it first looks for the correctness. And in NoSQL also, both of the things matter, but it first looks at the scalability. Okay. The next thing is that about data type and consistency needs. Okay. So we are coming to understand here like what is the data type and consistency need here, right? So when we should use SQL, when our data is structured and fixed, same format every time, needs strict rules and relationships must always be correct and consistent. Okay, so let me write these points down. Use SQL when, first point, structured and fixed. Second, needs strict rules and relationships. Okay. Thirdly, always be correct and consistent. Okay. Use SQL when I will add data here. Example, we all know it's banking, payroll, etc. So now I will write here use NoSQL when data flexible and keeps changing. Secondly, not every record looks the same. I will write looks same. Okay. Third, speed and adaptability matters more. Okay, so these are the points you can keep in mind to figure out on the basis of data type and consistency need to use SQL and when to use NoSQL. Okay, second point, this will be the first, and the second will be, and if you are wondering of what I'm trying to explain this on basis of, so this is on the basis of choose based on data type, consistency needs, scalability and performance. So I'm trying to explain this particular part here. Okay, so data type and consistency we understood. Now let's try to understand scalability and performance. Scalability and performance. Okay, so use SQL when data size is manageable, you want strong accuracy over extreme scale, and use NoSQL when you need to handle huge traffic and big data. Second, system must grow easily by adding more servers. Okay, so this is the things you should keep in mind when you are thinking about scalability and performance on the basis of whether to use SQL and NoSQL. So when this point one and point two matches with the database type you want, then you can go ahead with SQL or NoSQL. Okay, so this was how much I can boil down. I was able to boil down SQL and NoSQL and when to use them and what is the difference between them, right? In a theoretical manner, in a conceptual manner, right? Since this series is much more focused on SQL based, so I have not gone in depth on the basis or on the type how NoSQL databases the type is stored. Whether as I told you earlier, it is stored in the basis of JSON format, right? I gave you an example here. If you can remember, like this is the example, right? So this is the way basically the NoSQL databases data are stored. But since we are not learning NoSQL in this particular series, so I have not gone in much more depth on that particular thing. So this is all about SQL and NoSQL and when to use what. And I hope you understood this topic. Thanks for watching this module. Check out the next video in the beginners playlist. Explore other related modules there as well. Don't forget to like, share and subscribe.